Hello, my name is Jorgelina Alvarez and I'm a civil engineering student. My partner is Ramiro Alarcón and he's an electronic engineering student. We study at Universidad Tecnológica Nacional in Paraná, Argentina. Today, we are going to present our paper that is titled Groundwater Treatment, Iron and Manganese Removal by Geological Filtration. According to the NAE Grand Challenge for Engineering 2017 booklet, access to clean water for the entire population is a serious challenge for today's world. In developing countries, such as Argentina, people can only access to groundwater due to several reasons. For instance, the lack of infrastructure to connect to a water network, the distance from a fresh source of water, and the lack of investment from governments for water treatment, among other reasons. Although groundwater may be a solution to this problem, it is usually contaminated not only by naturally occurring poisonous pollutants, but also by human-caused contamination. Two of the most common pollutants found in groundwater are iron and manganese. Therefore, the aim of this work is to present the geological filtration treatment that uses bacteria to remove iron and manganese from groundwater. As a result, it has multiple advantages over traditional methods, as we will mention later.
Map of presentation. The presentation will address two key topics. First, the presence of iron and manganese in groundwater, their characteristics, and health effects due to the high concentration. Secondly, the biological filtration, its characteristics, methods, advantage and disadvantage will be analyzed. Next, please. Groundwater is, as the name implies, water that is found underground, is stored in aquifer, and is usually extracted by pumping. However, it is usually not very pure, as it's often contaminated by natural pollutant and human-caused contamination. Next. Iron and manganese are not common in the nature and are considered a form of pollution in fresh water. These can come from different sources of man-made pollution. Can come from different types of man-made pollution source. For example, natural dissolution of substance, industrial wastewater, mining, pesticides, domestic sewage, and waste from livestock and farms. Next, please. Iron and manganese are dissolved in water as divalent ion. As shown in the image, in large quantity, they can form dark-colored precipitate in water, giving it a dull reddish-brown color. Next, please.
In addition to what Ramiro said, I'm going to present the effects of high concentrations of iron and manganese in human health. As we mentioned, iron and manganese are two toxic environmental pollutants easily found in the lithosphere. These pollutants can lead to a significant impact on human health through drinking water contaminated. In Argentina, current regulation established that the limit of iron in water is 0.10 milligrams per liter, and exceeding that limit can cause several health problems, such as anorexia, diarrhea, metabolic acidosis, vascular congestion of the gastrointestinal tract, brain, spleen, and thymus. On the other hand, concentrations of manganese over 0.05 milligrams per liter can cause lung, liver, and vascular disturbances, a decrease in blood pressure, brain damage, and even death. Now I'm going to mention the traditional methods to remove iron and manganese from groundwater. These methods can be both physical and chemically based. They are ultrafiltration, coagulation, flocculation, and activated carbon. These processes add other chemical compounds to water to increase iron and manganese removal efficiency. This implies an additional operating cost and the generation of polluting chemical sludge. Alternatively, we present the geological filtration method that is based on contact oxidation of iron and manganese oxidizing bacteria. These bacteria are widespread in nature and are known as iron oxidizing bacteria and manganese oxidizing bacteria. In other words, some bacteria can oxidize only iron and others only manganese, but the ones using this method can oxidize both iron and manganese. This bacteria belongs to the genera of Leptotrix, Crinotrix, Hyphomicrobium, Siderocapsa, Siderocystis, and Metallogenia. The geological filtration method consists of three defined stages. The first one is the aeration of the raw water using a trickling filter. Secondly, the water passes through an upflow roughing filter. And finally, the process ends with a rapid sand filtration, as we can see in the field. This process can be carried out at natural pH and pH without using any special devices to control the dissolved oxygen in water. Finally, I'm going to explain what happened in the sand filter. There, the bacteria can multiply themselves and therefore oxidize iron and manganese and precipitate them under their oxidized form. As iron and manganese are oxidized, they are captured by the different sand filters, resulting in a suitable water for human consumption.
Okay. Among the advantages of this method, we can mention that it does not require a special condition to work, since it uses bacteria to oxidize iron and manganese. It does not require chemical agents. This avoids the generation of the chemical contaminants. It's a very efficient process with an efficiency percentage between 85 and 95%. In addition, it is a very economical process. Next, please. On the other hand, among the disadvantages, it's not a suitable process for large waterworks. It requires large amount of filtering stage to complete the process. This makes it a slow process. Finally, it can present complications at the time of cleaning the filters, demanding a great amount of workforce. Next, please. In conclusion, iron and manganese found in groundwater can be deadly. To purify the water, a special filtering method must be used. The biological filtration method is an effective, simple, and environmentally friendly method. It's an excellent choice for groundwater purification in rural areas where volumes are large. Next, please. This presentation is based on a review of this software. For more details of the process, please refer to the original research. Thank you very much.